Hi everybody, here's your first of 2 review lessons. This first one we're going to kind of make a little cheat sheet, and if you look in the content section under Exponentials review number 1, you're going to see if we were doing this face to face, we kind of made a 4-box cheat sheet. In any event, this is a good review for you, a good thing to have in front of you once we fill this whole thing out. Remind you of all the exponent rules, what the graphs look like, and then all the word problems that we've gone over. So what I have here to start are all of your rules for exponents. So remember, when we did these lessons, this was our first lesson, and I had mentioned that the final answer, you using your calculator, is only half the question or part of the question. So you coming up with the final answer is only going to get you 1 mark, unless I say otherwise. Every other instance, I'm going to say simplify using the exponent rules and then come up with the final answer, which means it's going to be more than 1 mark, which means it's not good enough to just show me that you know how to use your calculator. You also have to show me that you know these rules, or at least can refer to them because they're hypothetically sitting right in front of you. So when you multiply the same base, and again, remember the key to this, you can only use these rules when the bases are the same. You add, so add the exponents. So you leave the base the same, add the exponents. When you divide, you subtract, keep the base the same, and subtract the exponents. Power to a power, which just means you got back-to-back exponents here. You multiply, keep the base the same, and multiply the exponents. Power of a product. This just means you have 2 different numbers or a number and a letter inside the brackets. That exponent goes to everything. So basically what you do is A gets the exponent and B gets the exponent. Power of a quotient. Same idea. We have 2 things inside the brackets. That exponent goes to everything inside the brackets. So a to the exponent m, b to the exponent m. Add and subtract similar powers. This is just like combining like terms. A squared plus 2a squared. 1 of something plus 2 of something gives you 3 of something, so 3a squared. The trickiest one out of all of these, if you remember, is what to do with a negative exponent. So remember, there are 2 steps to negative exponents. I'm just going to simplify it by saying flip it, and the exponent becomes positive. How do you flip a? We have to remember, really, if you ever see a whole number, it's written over 1. So if you flip that, 1 over a to the positive m. For the second part of this time there actually is a fraction, so it's easier to remember how to flip this. B over a, and then make the exponent positive. And then you would just follow these rules right here after. The easiest one out of all of them, the 0 exponent rule. Anything to the power of 0, 100 billion to the power of 0, 1. That's it. So that's all of your exponent. The next thing, characteristics of exponential functions. So the first important thing you have to notice, your variable is the exponent. So you have some base greater than 0, and the x, or whatever variable it happens to be, is your exponent. Now, since anything to the, so we'll start with growth. So if b is bigger than 1, if your base is bigger than 1, it is exponential growth. And regardless of what you make b, we just know that anything to the power of 0 is 1, meaning it has a y-intercept of 1, assuming there's no transformations going on. And if you remember, as you go left to right, this is increasing. So it gets really, really close to 0, but doesn't touch it or cross it. And then it goes up, 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 and then it gets really high. And there is our exponential growth. If your base is between 0 and 1, which means it's like a fraction or a decimal, like 0.5, 0.4, 0.9, 1/2, 1/3, 1/10, anything like that between 0 and 1. That is exponential decay. And it does the opposite of growth. Still has a y-intercept of 1, because anything to the power of 0 is 1. But instead of rising as you go left to right, it's decreasing. And then it gets really, really close to 0, never touches it though, and never crosses it. So it gets close, doesn't touch it or cross it, and it kind of goes that. So as you go left to right, it's decreasing. And while we're here talking about exponential relations, one other key thing that we did when you are looking at a table of values, remember you go bottom up, and from grade 9, grade 10, even a little bit of this course, we talked about doing differences, which means you subtract. And if you get first differences equal, it's linear, second differences, it's quadratic. For exponential functions, we divide. So you would take all your y coordinates, bottom up, and divide. And if we call those ratios, so if ratios are equal, then you know it's exponential. And those are all of our key characteristics for exponential functions. The last couple of lessons we worked on modeling, which just means word problems. And I gave you a general form of an equation. So we're going to start with growth. So I gave you a general form. I gave you all those things. P is the starting amount, A is the final, R is the growth rate of the decimal, and T is time. And I'm just going to come up with a fictitious example here. So we'll say, doesn't matter what game, but we'll say Tyler gets 2 points per game. We'll say he practices, and we'll say as he practices he gets better, and we'll say his skills increase by 8.6%. How many points will he get on the 12th game? Or I'll say 12 games from now. So we know that it's exponential growth because it says increase. So if we're going to come up with our equation first, A equals the starting amount. He starts by getting 2 points a game. 1 plus. Now don't put in 8.6. Remember, that's a common mistake. You're going to get a huge, huge number. You have to make that a decimal. And don't forget, to make that a decimal, you have to do 8.6 divided by 100. So that gives us 0.086. And the amount of time, 12 games. If we round to 1 decimal place, if you enter that just like you see it, brackets and all, 5.4 points. And then don't forget a therefore statement. The next thing that we did that definitely is a growth question, but we did it in our part 2 because it has a specific equation, is doubling time. So we still have A, still have P, still have T for time. The only thing that's different is you have a 2 there because it's doubling, and you have the letter D for doubling time, or the amount of time it takes to double. So let's keep our kind of same example. So we'll say Tyler still gets 2 points per game, but this time we're going to say his skills double, or his ability to get points. His skills double every 8.6 games. This time, how many points will he get 24 games from now? Now we know that it's doubling time because it says double. That's your visual cue. So A equals starting amount, which is 2. That 2 in the brackets is always there. And then time, we want 24 games, and hit doubles every 8.6. Do not forget, so I'm just going to make a little note here. Calculate the exponent first. So I'll let you do that on your own. Calculate the exponent first, then do 2 bracket 2 close bracket to the exponent, whatever you get. When you round to 1 decimal place, you should get 13.8 points. And then don't forget a therefore statement. So there's 2 made up on the fly examples for exponential growth. The last thing in our review, exponential decay. And the only difference here for decay, remember, is that we have a minus because it's decreasing. So let's say, we'll stick with points. We'll say Jessica. So we'll say Jessica's skills decline by 3.3% per game. We'll say she averages 13 points per game. How many points will she have 12 games from now? We know this is decay because it says decline. So our formula format, final amount, starting amount, she gets 13 points per game. This time instead of plus, it's minus. And don't forget to convert that to a decimal. 3.3 divided by 100. 0.033 to the exponent 12 because it's time is 12 games from now. Enter it just like you see it. brackets and all, don't add anything. 1 decimal place should get 8.7 points. And don't forget, therefore statement for word problems. The second thing that has to do with exponential decay, which was a part of our second word problem lesson, HalfLife. And remember, I have 1/2 written here, like as a fraction, but if you don't like that, remember you can do 0.5 if you would like. And then if you're more comfortable, go for it. So we'll stick with the same kind of scenario here. We'll say Jessica still averages 13 points per game. We'll say her skills have every 3.3 games. How many points will she have 24 games from now? We know it's HalfLife because it has the word half in it, or have, or skills have. So we know we're using this formula. A equals starting amount, which is 13. We'll assume you don't like fractions, so I'll put 0.5 in there. And then time 24 over doubling time, which it says it takes 3.3 games for her skills to erode by half. Do not forget to do the exponent first. I'll leave that up to you. Enter just like you see it, and you should get 0.08 points. So basically nothing. By the 24th game, she's not getting any points. And that's it. For your first review, we made a nice little cheat sheet for ourselves. The second part of the review is coming up next. You could work on potentially your review in your workbook, or you could go right to that second review lesson, which is just like a practice test. Do not forget that your test is in the afternoon today. Still going to have just over 2 hours to do it, but you're going to have to do it or start it at least between 12:55 and 2:55. And if you haven't happened to watch the video that I posted on Hasia last week, or you didn't watch it in the content section under online stuff where it says how to check your mark, I have tried to provide a reward for you. So just a reminder, if you can submit your test solutions to me all as one file, meaning all in a Word document or all in a PDF as opposed to just a series of pictures, I will give you 2 bonus marks on your test. So 2 easy bonus marks just for doing kind of what I hope that you're able to do anyway. So depending on when you're watching this, if you're watching this in the morning before the test and you have time, maybe try to practice. Put some pictures into a Microsoft Word document and save it as a Word document, or even in Microsoft Word, you could save it as a PDF. While I think of it as well, if you can avoid, take pictures of single pieces of paper. Please don't put 2 or 3 or 4 pieces of paper all side by side and then back up or zoom out with your camera and take one picture of all 4 pages. If you do it that way, the resolution is really low, meaning when I go to give you a mark on it, I usually, for those of you that have been doing it, I have to zoom in to see it. And then as soon as I zoom in, it starts it reduces the resolution and makes it blurry. So please just take pictures of individual pages and then either import those all into a single Word document, save it as a Word document, or save it as a PDF. Or if you've learned how to use Genius Scan or anything else similar to that, some of you have. Again, my challenge to you, learn how to do that, and you'll get the 2 easiest bonus marks on this test, on your finance assignment, and on your finance test. And potentially, if we're still online, on your CCA. So again, just a quick reminder about that. At some point today, make sure you watch the second review lesson, prepare for your test, your second last test of the year. That's it. We'll talk soon.